So our topic today is VVT system diagnosis. It's been a little while since we've talked about variable valve timing and variable valve lift systems, and not a lot has changed since the last time we talked about it. But it's always good to have a nice little refresher, right? So a couple terms that we're going to use. We have VVT, which stands for variable valve timing. So that's going to control the camshaft timing itself. So it advances or retards the timing depending on which way it needs to go, and it uses the cam gears in order to do that. And then variable valve lift is going to be VVL. So changes valve lift and duration because you can have alternate cam profiles the way it works. Uses multi-lobe cams to get that done. And there's also other ways that we can get this done, as we'll see a little bit later on in the presentation. So let's talk first about VVT and their components. So the cam gear is, like I said, where it all basically happens, and there's variables throughout how each manufacturer does it, but internally it's roughly going to be like this. So a tooth gear is driven by a belt or a chain, depends on the vehicle. Camshaft is going to be connected to the center, of course, and it's hydraulically controlled. So within this, we have the outer sprocket, of course, up here. Some oil passages internally to allow the oil to move throughout these passages in the oil chambers there. And we have the vanes to separate two sides of those oil chambers. And that's how we're going to advance and retard the timing. To make the oil go where we need the oil to go, we're going to have a couple different oil control valve types. So the first one is a spool type valve. So you oftentimes see these sticking in the top of the head or whatever. And it's got this little spool in the middle. And it's modulated, open or closed. It can be just moved back and forth. The computer controls either the power or the ground side, depends on the manufacturer's discretion. And like I said, the spool valve moves in or out depending on how they're controlling it, how they're opening and closing it. Some manufacturers also use an actuator solenoid, so it actually pushes out of the middle here. So these would be mounted in the front of the timing cover, and they will push out. Subaru uses this style. I think there's a couple other manufacturers out there that use this style as well, but it's got this little pin here that pushes on the center of the gear. So in this case, the spool valve is actually integrated with the timing gear or what have you. So it pushes on that and it moves that in and out depending on where it needs to be, where I need to advance or retard the timing, and that just kind of spins there and just pushes on that little dot as it's spinning by. And then we also need, of course, to be able to get the oil to this because it's oil actuated. So we need oil feed lines as well. So oftentimes you'll see just the metal lines. Could be some rubber involved. And then, of course, you have these banjo bolts. Some of the banjo bolts will have a filter in them. Usually the ones with the little nub at the end are going to have some sort of a cleaning filter in there just so no gunk and crud gets into the actual system itself or into the gears, or at least it tries not to get into the gears. So that is can be a maintenance issue and can cause failure. It could be a failure point right there. And then, of course, when you replace them, they are banjo bolts, so you want to replace the washers as well. So let's look at the operation here. So when the valve is closed, it's going to default to kind of a neutral setting wherever it needs to be, wherever the manufacturer decides that needs to be. Sometimes it can be slightly retarded, sometimes slightly advanced. But when the valve is closed, it is going to hold that oil pressure wherever it needs to be. So in this case, we're at 50-50 right now. So nothing's going on, nothing's coming in, nothing's going out. Oil would be coming in this way, and then it's going to go on either side. So in this case, it's closed, and we want to advance the cam. We're going to go one way, so it pushes it out. So that allows the oil to go in on the one side and the pressure to increase on that one side, which slides it over. And then it allows the other side to drain back out. So it's got to have it's being displaced, so it needs to be drained back to where it was. And then to retard the cam going the other way, we're going to do that. So the oil comes out on the blue side, and then it'll be going back in on that red side there. So it's going to be supplied through the middle, and then just depending on which way that spool valve goes, it's either going to go through the one side of the chamber or the other side of the chamber, and then it is going to advance or retard the cam accordingly. Because if you think about this outer gear is going to pretty much stay the same. It's going to be within the same to keep the timing the same between the cams and the crank. That pretty much stays the same. It's the camshaft on the inside is going to be moving uh, kind of backwards and forwards, and it's hydraulically connected. The inside and the outside are hydraulically linked in that way with that pressure. So variable valve lift now. So this is quite a few manufacturers use this now. Honda was probably the most famous. They did this way back in the 90s with their VTEC system, which is variable valve timing and lift electronic control. So what that does is it uses a special cam, which, like I said, other manufacturers do this as well. It's going to have low side and high side cam, right? So we got the high lift lobe in the middle, and the low lift cam lobes on the outside. And basically, what happens is you can change the lift, and you can also change the duration. If you want to change the grind of the cam, you can do so. Manufacturer's discretion. So boils down to that and the rocker arms. So on the rocker arms, these are also hydraulically oil controlled, and it has these pins in here. So they have these little pistons, they call them, but they're really just metal pins that go back and forth. Return spring to move them back and forth, and then we put oil pressure on the other side to make it move. So we have a primary rocker arms and secondary rocker arms, and then there's the middle rocker arm in there. Like I said, we need a valve in order to move that pressure around, or to either side of the rocker. So the oil control solenoid just opens and closes, and it also has a pressure switch on there for the USA and Canada models, anyways, of this. But that valve will move up and down in there. We got a little solenoid there, and it's very similar to those spool solenoids we were looking at before for the variable timing. This is for the variable lift. And then how it works is when the system is off, it is just going to kind of sit there, and the oil is going to be going into the valve, but the valve is closed, not allowing any oil to pass. So its default setting is going to be the spring pushes out this pin, and it's just going to sit there in the middle. And you notice how there's a break in between the pin on this side and this side. So that means the rockers will follow the outer cams, right? Because those are riding directly on those outer rockers. These are the rockers here. It's just a cross section, right? So it's going to go like that. It's an oil passage in the middle. When we want to turn the system on, it is going to open up the valve, pushes down here, actually uses the oil pressure to push down on the valve. We've got a little solenoid there that pulls it up. Pulls up a little valve there, I guess, and it pushes down on this valve, which allows oil to pass through the passage, and it pushes oil pressure on the other side of the pins, which forces them in and forces them to lock these outer rockers to this inner rocker, and then it is forced to follow that high lift cam in the middle. So when it's just sitting there off, let me back up a slide. When it's sitting there off, this pin in the middle it's not doing anything. It's just sitting there, and it's allowing that high lift cam is still obviously going to be turning, but it's just kind of flopping around in the breeze. It's not directly connected to a valve. It's just a little, I guess, a little pin or something that it rides on, just to make it less noisy, I suppose. And then when it locks together, like I said, it goes on that high cam like that. So fairly simple system. I mean, if you think about it, it's a couple pins and so on. You do have to be careful when you're working on it that the pins don't drop out or anything like that. Subaru uses this similar system on some of theirs, and we had a special tool actually to clip it in and to hold it in place. So if we had to remove the rocker assemblies, they wouldn't fall apart like that, right? All right, now let's move on to electronically controlled variable valve lift, which would be BMW's valvetronic system that they use. So that uses some solenoids that changes the profile of the rocker, and that works in a similar fashion, right? So we have these little solenoids here, and you can see how we have the rocker kind of shifted down like that. The camshaft is gonna push down over here, actually over here. Sorry, camshaft pushes over here, so this is an eccentric. So as it moves over, it'll push it further out, which will allow the camshaft to change how it opens and closes the valve. So we can see right here, this would be with the system off and actually kind of idles on that. We can have them fully closed to fully open. We'll get a little animation that we can show you here. It kind of shows you a little better how that works. So this is normal operation. That's very small lift, and then actually can go to full off, where it's just sitting there, and then there's a little bit of opening, and then there is wide opening, right? So it can go anywhere from that and anywhere in between. Just kind of goes back and forth. There it is, fully off again. Just riding on those rockers, not pushing them down, and then it pushes them down a little bit, and then it pushes them about down a considerable amount. And actually, you can change which valves open and close by doing that as well. You have just one open and one close, depending on what the time, what it happens to be. So let's talk about some problems that we might run into, and probably the two most common codes you're going to see for these problems. There are other codes, of course, but the two most common ones that you see out there. Go to any automotive forum or anything like that. As hey, I got this P0011 code or a P0021 code. Intake camshaft position, bank 1 or bank 2, and manufacturers can put little modifiers on whatever they want their description to be. But basically what happens is the problem is there's not enough oil pressure in the system, and then it just goes to default. So it goes to slightly retarded or slightly advanced, whatever their default setting happens to be. If there's not enough oil pressure, basically it just shuts the whole system down and it just doesn't do anything. And then it throws that code. Oftentimes it's just, hey, did you check your oil? And sure enough, the oil's low. Or other times it could be, well, my oil's full, but I have debris, right? So we have clogged passages, dirty passages. This is due to, obviously, if you can tell, it's all the very silver sparkly stuff, internal engine damage, possibly also due to low oil. But it can go in there and clog all that up. And remember how earlier I said some of the banjo bolts on the oil passages or the oil piping will have like a little nub on there, and then there's actually a filter in there. So it's a removable filter. You can pull it out, clean it out. That's what we used to do all the time. We just clean them out as a matter of course sometimes. When we were in there, you just clean them out just to solve problem or just not have that problem going down the road. This actually appears to be one of the spool valves themselves is corroded up there. All right, so let's go live on the tool and take a look at a few things we can see. We'll look at some repair information, some just different system tests we can do. There should be different guided component tests we can do too. So let's take a look. All right, let's take a look. So first one, we'll pull up Honda. So go into the scanner, see what we can see. So of course, all that stuff's going to be under engine. And in this case, they'll be under functional tests. Gotta wait 10 seconds. Okay. And let's see, we got a couple different ones here. So we have the VTech test. So that'll go through and test the functions of the VTech system, automated test. Can't do it with the simulator. It just kind of stops. Then variable timing control. So that'll be for the actual timing, not the lift. So we got the timing, cam timing, and then the cam lift. That'll be intake variable timing. Activates the VTC valve to 3 stages and monitors each position from input voltage of the cam sensor input against target angle commanded by the ECM and PCM. There can be a difference between actual angle and target of 3 to 5 degrees. The purpose of this test is to duplicate a VTC system failure for a P0011. This test will not execute if any other codes are set. For the Type R and the Integra, ECT sensor must be 185 degrees. Hybrid vehicles, batteries fully charged, test may fail. Batteries fully charged, the test may fail. In that case, perform EVTC learning to reduce the amount of charge and try again. Couple different, depending on what you have for an engine. So 2 liter is must be done with ECT sensor under 122 degrees Fahrenheit. And then at 3 liter, ECT sensor must be 85 degrees or higher to perform this test. So 185 degrees Fahrenheit. So depending on what you have for an engine, the manufacturer demands different temperatures, right? So, or different things that we need to do. So we always got to be aware anytime we're doing any sort of functional test that if the manufacturer says, hey, you need this, the test will fail if it goes outside of that. So just so you're thinking about that. And in this case, it says there's DTC, so it's not even going to let me into the test. So with the simulator, it automatically has DTC stored. So that's functional tests. Let's look at got a component test for this. Under engine again. So in this case, we have the VTC solenoid itself. So that's a variable valve timing control solenoid A and B. So we have one for intake and one for exhaust, depending on what the vehicle is equipped with. Mounted in the cylinder head, right side of engine, below the camshaft timing gears. ECM, PCM controls the variable timing control and oil control valve by calculating signal from the selected sensor to optimize power output, lower emissions, and fuel consumption. Changing duty signals to the OCV, ECM can adjust intake cam phase. If malfunction occurs, it is disabled, and valve timing is fixed at a fully retarded position. So that is its default setting. And then it looks like we can do a resistance test on it. Should be 6.75 to 9.25 with the key off. And then for the VTEC system, so we have the pressure switch on the solenoid. So on the solenoid, it just tells you it's a rocker arm oil control solenoid. When activated, changes the cam profile to correspond to the engine speed. It maximizes torque at low engine speed and output at high engine speed. Low lift cam is used for low engine speeds, and the high lift cam is used at high engine speeds. And then you would test it at the solenoid itself. And we can do a voltage test and a resistance test. So a voltage test would be 0 volts indicates no rocker arm control operation. Accelerate vehicle to an engine speed about 4,000 in gear for at least 2 seconds, and battery voltage will be present. So just that must be where the VTEC changeover is in that case. All right, and then I can do a resistance test on there as well. It should be 14 to 30 ohm. And let's look in Chopkey. Okay, so let's see if there's any codes for that. No, it doesn't look like it. All right, so in this case, the valve itself, the variable timing control, rocker arm oil control valve, and VTC oil control valve. So this is for the VTEC solenoid rocker arm control valve, right? Rocker arm oil pressure switch. And then there's the VTC oil control solenoid. So that's for the variable timing. You can even see some tests we can do with it. Make sure there's no debris on the solenoid itself. If you want a little bit better look. Easy enough to get to. Okay, some tests as well. That's because it's the same information as before. Okay. All right. And then we also have a BMW here, so we can look at a little bit on the valvetronic. This. Oops, I didn't want to do that. Let's try that again. No. Go to the engine. Functional test, that's under a special function. And there's actually two here too. So we have the valvetronic. So we have a startup valvetronic and a valvetronic limit learn. So if we following test is necessary if the valvetronic servo motor was changed, if teaching in errors are present or adjustment problems are present, control deviation errors are present for the microscopic smoothing of the eccentric shaft. So that's for the that eccentric shaft that pushes on the upper rockers, and it deletes the valve adjustments, and then turn the key on and off, and then it'll teach on the next step. Now in this case, it's going to say there is a code, valvetronic fault, right? So if there is a fault, you can't do it. You got to do it, eliminate the fault and do it again. Continue with the test. Procedure is completed successfully when it's done. And then we have the valvetronic limit learn, which needs to be done each time after repair work has been carried out on the valvetronic system. Limit positions on the adjusting mechanism must be relearned for a minimum and maximum lift. During their adaptation process, the eccentric shaft is twisted slowly in the direction of minimum lift until a point of mechanical resistance is reached. This position at the mechanical limit is stored, and the same procedure applies to maximum limit lift position. So it's going to do a ignition cycle. We got to wait 15 seconds. Okay, and then it's waiting for enable, and I can't enable it once again because I am in sim mode. So what it would do is it would move them like that are full open and full closed. And there we go. We'll move them, they're full open and full closed, and then like I said, teach in where those go. And then we have the solenoids for the inlet and the exhaust. And in this case, it's not going to do. It's just going to say it can't communicate because once again, in the simulator mode, so you can. There are functional tests for the intake and exhaust Vanos solenoids as well, and that is for the timing. So valvetronic for the lift, Vanos for the timing. Okay, and then in guided component tests, we should have some tests in here as well. So we have the valvetronic motor test. VVT sensor is integrated inside the VVT motor. No access to the sensor is available and cannot be replaced. They have 5 Hall sensors determining eccentric shaft and motor position via the 5 Hall sensors. Okay, so there's just a signature test that we can do on that, and it's going to look like this. So it's going to be a pulse width modulated. And then for the VVT position sensor, like I said, there's 5 different Hall sensors, so it's got tests for each. And you're just going to check and see if it has a signal as it moves back and forth. Right, so it's going to give us that information, and then here's like the computer. When removing the VVT motor, you must follow the BMW repair instructions, or damage to the VVT system may occur. Very true. If we go in here, go VVT. So in this case, we can go into remove and replace. And boy, there's a lot of stuff in there. Right? Look at all these different articles for that. So I'm just going to scroll down a little bit. Remove all that stuff. Oh boy, remove all that stuff. Lots and lots of stuff to get to that. A lot of special tools. More special tools. Central valve there. So there's what that looks like. And there's a special tool for that. It's going to be slightly different on each different engine too, but you can kind of see a pretty good look of the eccentric shaft and then the rocker assemblies there. All right, and then parts. You can find parts on that. So actuator, $550 for that thing. $550 for that little motor. My goodness. $70 for number 18. What's number 18? Actuator. Picture. There we go. Oh, that's on the front. So it does appear that BMW uses a very similar system. That's the Vanos solenoid would be very similar to what Subaru uses. We talked about where it pushes on the little spool valve itself. So that is what they use on that one. That's $70. So the fancy one for the fancy Valvetronic is going to be $500 and then $70 just for the cam timing. So 11 hours and 10 hours all with or without active stabilizer system. So yeah, it's 10 or 11 hours to do the that thing. So like I said, a lot of stuff you got to remove in that particular case. So have fun with that if you ever have to do that. So that is variable valve timing, variable valve lift. Hopefully we've learned a few little tips and tricks on that, and I'll just go through and follow the manufacturer's instructions is always the best way to go about that, especially on these systems where there's a lot of stuff involved with that. Always remember they're oil actuated, many of them as well. So you need to make sure you have good oil pressure and clean oil. So oil changes are important for the customer. And if they don't have good maintenance, then that may be your first thing you need to look at when you're working on one of these systems. So that's variable valve time. Let's talk about what we're going to talk about next week. So next week we are continuing on with our OEM specific ADOS training, and next week we are on to Toyota. So we're going to talk about some different things. Toyota is a little bit different than what we talked about last week with Ford because they have way more targets. I'll tell you that, and the systems are a little bit different, and they are a little picky with the lighting. Is what I'm showing you right here on the slide there. So same time and same place as always, every Tuesday, 6 and 9 Eastern. If you want to watch on Zoom, go to snapon.com/OT to watch over there. Otherwise, the 6 p.m. class goes live to our YouTube channel. If you scan that QR code right there, that'll bring you to the YouTube channel and subscribe you automatically. And then the 9 p.m. Eastern class goes live to my Facebook page. So it's facebook.com/SnapOnJason. All one word, no dash, and Snap-on. If you want to see any of the other classes in this series, anywhere from Intro to ADOS, which is the very first one we did back in 2020, all the way to OEM specific ADOS on Ford. And then, of course, this will be episode 106 archived up there pretty shortly. So hopefully you can check those out. Like I said, they're free, all 30 to 40 minutes roughly, give or take. And, give you a little bit of information on really just about anything you want to learn diagnostically. Also, do we have your email address? If you don't have your email address, then you may be missing out on some really good information like technical focus articles, sure track blogs, quick tips, new product releases. They send out my schedule, I think monthly usually. So you'll know everything that's going on within the diagnostic world as far as Snap-on's concerned. So you can scan that QR code right there, and that'll bring you to a page where you can sign up for our email list there. Lastly, we got Q&A here. So as I said earlier, this is a pre-recorded session as I'm traveling this week. If you do have any questions, feel free to, on Zoom, you can respond to the email. If you can't get them in right now, because I'll be monitoring the chat, and I can type in the answers, or you can reply to the email that you got, an email confirmation that you got. If you're watching on YouTube, feel free to leave a comment, and then on Facebook, same thing. Feel free to leave a comment, and I'll get to those as best I can. Also want to make sure before I leave, I mentioned my buddy Keith, who also does free online diagnostics training, and it is tool-based diagnostics training. So Wednesdays on Zeus and Zeus Plus, and Thursdays on Training Apollo tools. They're all about an hour and a half, hour and 45 minutes long. The first hour's setup instructions, buttonology, talking about a lot of the scan tool functions. He walks through from soup to nuts on intelligent diagnostics. Then it takes about a 5-minute break, and then after the break, we'll be all on got a component test and scope and meter functions as well. So definitely worth your time if you want to learn a little bit more about your scan tool. And times are down there on the bottom. Go to snapon.com/OT to sign up for that. And with that, that is the end. So I'd like to thank you very much for spending a little bit of time with me. Hopefully we'll see you next week for our ADOS class on Toyota. With that, enjoy the rest of your week. Enjoy your weekend. Have a nice night and take care.